Hello guys, welcome to another video with the number ninja. This video is very comprehensive. So it is a comprehensive package for students that are preparing for the IGCSE exam, WAEC exam, JAM exam, PSN Edexcel and AQA exam. So this is a complete tutorial on everything you need to know about circle theorems for this exam. So without wasting much time, let's get started. Before that, please, if you are new to this channel, please subscribe to the channel so that you can get notification of my videos. Okay, like the video and turn on the notification bell so that you can always get notification whenever I post new videos. Okay, like I said earlier, this is a complete package on circle theorems for IGCSE exam. Now the first thing we'll be looking at is what we call the symmetry properties of circle. Now circle theorems for IGCSE exam. Now there are 10 theorems. Okay, there are 10 in number, so you have to know. Now we are going to take them one after the other. Okay, now the first one is theorem 1. The perpendicular bisector of a chord passes through the center of the circle. Okay, through the center of the circle Now what this is saying, that this is the chord. My chord here is this line. This is the chord here. Okay, chord AB. Now it's saying that the perpendicular bisector of this chord. So now if I call this point let's say point C. Okay, this line OC is the perpendicular because it meets the chord at angle 90 degree, right? Okay, that's why it's perpendicular, and it's also a bisector. Now because this line OC it cuts this chord into two equal parts, so which means the distance from A to C is equal to C to B, right? Because this line here OC, it bisects this chord AB into two equal parts. Okay, and also it is perpendicular to it as well, and again it must pass through the center O. The center is always labeled as O. Okay, take note of that. Now that's what the theorem 1 is trying to say. Now let's see how to apply that theorem in in questions. Now I have chord AB is drawn on a circle with radius 7 cm. Okay, now this is my chord. This line is my chord is AB. It is drawn in the circle, as you can see. Now the radius of the circle is 7 cm, so which means radius means the distance from the center. Okay, center is O. Distance from the center O to this point B, okay, is a radius. So my radius R, okay, is 7 cm, right? Now we are told that if the chord is 3 cm from the center of the circle, so the distance from this chord, okay, distance from point P to the center O is 3 cm. Okay, don't forget this point P is a midpoint. Okay, that point P must be the midpoint, okay, of the chord AB because of theorem 1. Okay, all right, then say find the length of the chord to two decimal places. Now we are going to apply Pythagoras theorem here. Okay, why? Because we have a right angled triangle here. So I have a right angled triangle on OPB. All right, so we are trying to get the value of this side BP. Now this side PB squared is equal to side OB squared minus OP squared. Okay, that's from Pythagoras theorem. Okay, now the value of OB, OB is 7, so I have 7 squared minus the value of OP, is 3, so 3 squared. So I have 49 minus what? 9. That gives us 40. So now the value of PB, okay? Now I have PB all squared here, so I have to take square roots, isn't it? So as to eliminate this square. So my PB becomes square root of 40, okay? You can leave your answer in solid form. So this is solid form. That's solid form, okay? Now, the value of PB is square root of 40, okay? Now, but we are asked to find the length of the chord. Now, the chord is actually the distance from point A to point B. That's the chord. From point A to point B is the chord. Now, don't forget, the distance from point A to point B is twice of PB. All right? Because this PB is like half of the distance from A to B. So, which means that's why I have to double it. So, multiply square root of 40 then times 2. Okay? This gives us 12.65 as the final answer. All right? So now that's all for theorem 1. Okay, now to theorem 2. Now theorem 2 says that equal chords are equidistant from the center of the circle. From the center of the circle. Now, what does this mean? Now, this means that if I have equal chords, now I have two chords here, chord AB and chord what? Chord CD, okay? Now, those chords are equal in length because they are equal chord. So, which means AB is equal to what? CD, all right? Now, this theorem is saying that if I have two equal chords, okay, in a circle, now the distance from the center of those chords to point O are the same. So what that means is that the distance from the midpoint of this chord AB, so which means distance of the midpoint of chord AB, that means OM now, okay? This point M is the midpoint of chord AB, right? This point N is the midpoint of chord CD, right? Very good. So now the distance from those midpoints to the center of the circle, that means distance from distance OM must be equal to distance ON, okay? So this is what this theorem is trying to say. Equal chords are equidistant from the center of the circle, all right? So don't forget, these angles are all 90 right angle degree, right angle, just like so. Now, all right. So I have an example here. So we are given that O is the center of the circle, radius 11 cm. Okay. Now we have that A, B, and C, D are chord. These are two chords. I have chord AB and chord CD. Now AB is 14 cm. Okay. So which means the length of chord AB is 14 cm. Now this X, of course, is the midpoint of AB. So which means distance AX has to be 7, okay? Half of 14. Distance XB has to be 7, right? Exactly. Now don't forget, our chord AB and CD are, okay, they should be equal. So which means distance CY also 7. This is 7 cm here too. 7 cm. Distance YD, this is 7 cm as well. Now we have if OX equal to OY, so which means OX equal to OY. Okay, so I can just mark these two line because they are equal. You say find the length of OY to 2DP. So which means I'm giving all those information. So I can lift out this triangle. You can pull it out, this triangle, okay? If I do that, I'm going to get this right angle triangle, okay? This is O, this is Y, this is D, this is 7 cm, this is 11 cm, okay? Now I can use Pythagoras theorem to get the value of OY. So I have OY squared is equal to what? To be 11 squared minus what? 7 squared, right? I have 121 minus what? 49. So which means OY squared is equal to, now let's get that subtraction done. So I have 121 minus 49, which is 72, okay? 72 here, so so I have 72 here. So which means OY will give us square root of 72, right? So square root of answer. So I have 6 root 2. So I'm leaving the answer as solved form, 6 root 2 centimeter. Then now we are asked to find the value. Say find the length of OY. Oh, I'm done. That's the answer. So OY is just 6 root 2 now, but we are asked to give it to 2 decimal places, so I cannot stop here, okay? Now 6 root 2, if I press the XD button, I'll get 8.49. That's 8.49. So that's the answer to 2 decimal places, 8.49 centimeter. All right. So please pause the video and attempt these tasks. So you should know the law, the theorem to apply here. Okay. So this question will involve theorem 1 and theorem 2 as well. Okay, so now let's figure out this one. The diagram shows a circle, center O, okay? Don't forget, center is always O. We have PQ and QR are chord. So this PQ and QR, there are 2 chords. It says OM is the perpendicular line from the center O to PQ. So I have this OM, okay? Okay, is there? Okay, now I say complete the statement. PM ratio PQ equal to dash ratio dash. Now let's see. Now I have PM. Look at PM ratio PQ. Now don't forget. We said that PQ, okay? PQ is actually twice of PM. Okay. So which means that PM, that means that PM actually is like half, okay? Half of PQ actually. Don't forget from theorem 1, okay? Because this point M, okay, is the midpoint. So which means PM is like half of PQ, right? Now this gives us so which means PM ratio PQ give us 1 ratio 2 actually. Okay, because from here now I have PQ is equal to 2 PM, right? So if I write PM all over PQ, okay, this should give us 1 all over 2. Yes, 1 over 2. So that this gives me the ratio. So PM ratio PQ is 1 ratio 2 actually, okay? And that's the answer here. Now ON is the perpendicular from O to QR, okay? It says ON, this line here is the perpendicular line from the center to QR, okay? Then and PQ is equal to so which means chord PQ, this chord is equal to chord QR. All right. So which means we can apply theorem 2 here. Wow. Now it says complete the statement to show that triangle OMQ, triangle OMQ, which means I have to join, I have to connect O to Q, of course. So if I connect O to Q, that gives me that triangle. So I'm seeing triangle OMQ now. Triangle OMQ. This triangle here, okay? Now is congruent to triangle ONQ. To ONQ. Wow. Of course. So now basically, now please consider these two triangles. Now we have triangles like this. Look at two of them. They are like this. So this triangle, this one came from here, and this one came from here like this. Just like so, like this. Now both of them, you can consider this is M, this is Q, this is also Q, because this Q is like shared among them, right? This is O, also O, because O is shared among them. This is my N, okay? Now when I combine these triangles, I'll get this shape here, right? So triangle OMQ is this one, triangle ONQ is this one here, right? Wow. Now those triangles, they are similar. Yes, they are similar triangles, of course. Now we are trying to complete the statement. Now I say dash is a common side. Now you can see now it is very clear that the common side here that they have in common is OQ. Okay, so which means OQ is the common side here, right? Now dash equal to dash because M is the midpoint of PQ, okay, and N is the midpoint of RQ. Now let's check that. M is the midpoint of PQ, of course. Then N is the midpoint of RQ, of course. So dash equal to dash because of those reasons. So what are equal? So let's see. Complete the statement to show that triangle. Okay, so don't forget we are trying to show that this triangle OMQ is congruent to triangle ONQ. Okay, actually. So now basically what happens here is that is basically that you know, now since M is the midpoint of PQ, so which means that MQ, distance MQ must be equal to distance NQ. Yes, they are equal because M is the midpoint of PQ and N is the midpoint of RQ. Okay, so that's the answer here. Now dash equal to dash because equal chords are equidistant from dash. So how do we complete this? Now from theorem 2, now you will remember that equal chords are equidistant. So for that reason, the distance from the midpoint to the center, which means I have distance OM is equal to distance ON. Yes, because equal chords are what? Equidistant from what? From center, right? So center will be here, center O will be here. So this is the complete answer to this question. Okay, wow. Now this is the math scheme, so you can see, so here are the answers. Very correct. Yeah, OM, ON, yeah, MQ, NQ, yeah, center or O. Correct. So you can either write center or you can write O here. Okay, that's fine from the math scheme. All right. Now please pause the video or attempt this question. Okay, you can solve this question using theorem 1. Okay, Also this one, attempt it. All right, so now on to lesson 3. We are done with theorem 2. Now theorem 3, now it says that two tangents drawn to a circle from the same point outside the circle. Take note, now the point must be outside the circle. Okay, now this point P here, you can see it is outside the circle, right? Very important. Now if I have two tangents, now first of all, what is a tangent? Now a tangent is a straight line drawn that touches a circle at only one point. Now this line AP, look at line AP and line BP, they are both tangents. Now line AP touches the circle at only point A, right? Look at only this point A. Now line BP touches the circle at only point B, right? So now that's a tangent. A tangent must touch the circle at only one point. Okay, so that point is called the point of contact. Okay, so the point where the tangent touches the circle is called what? It's called the point of what? Contact. Okay, take note of that. Now we have two tangents. Okay, I have two tangents drawn to a circle from the same point, that's point P. Okay, point P outside the circle. They are equal in length. Wow, they are equal in length. Now what this theorem is trying to say is that if I draw two tangents from a point outside the circle, okay, that's point P in this case. Now the lengths of my tangents must be equal. That's all. That's why these marks are here. So this mark means that these tangents are equal in length. So which means tangent AP is equal in length to tangent what? To tangent BP, right? Now some other things happen. Now this angle here is bisected. Now this line is called line OP. Now this line OP is a bisector. Okay, line OP is a bisector. Now which means line OP, it bisects this angle. So this angle here, okay, is equal to the angle here, like that. So this whole angle at O, okay, is bisected. Okay, so the angle here is equal to the angle here, right? So which means if this is like, let's say x degree, this is also x degree. Okay, they are equal. Now same thing happens here. So the angle here is equal to the angle here, okay, because a bisection happens here as well. Okay, so which means this my line OP, okay, is a bisector. So it bisects this angle here, okay, and also this one as well. Okay, take note. And one more last thing you must know is that the angle formed here is 90. Okay, right angle. The angle here is 90. Okay, right angle, very important. So now which means in theorem 3 we have 4 key points here. Now the first one is that tangent AP is equal to what? Tangent BP, right? That's the first point. Now the second thing that happened is that this angle which is called angle AOP is equal to angle what? To angle BOP. Yes. Okay, because line OP has bisected that angle, right? And again, angle APO, okay, must be equal to angle BPO, of course, like that. So that's what theorem 3 is trying to say. Okay, now I have this question. I have point A, C, and D lie on a circle center O. All right, now BA and BC are tangent to the circle. All right, So which means look at BA, look at BC. Don't forget the exterior point is point B, right? The point outside the circle is point B, right? Very good. Now the angle at B is 32. So which means, don't forget from what we just learned now, that this angle is bisected. So I'm going to bisect 32. So which means this is 16. This also what? 16, right? Very good. And don't forget, I said the angle here is 90, right? So which means the angle from this line to this tangent, this angle is a 90 degree, right? Right angle. So which means now if the whole angle here is 143, so what is this extra angle here? So I'm going to do 143 minus 90 degree, right? To get that angle space there, right? So I'm doing 143 minus 90 degree. So I have 53 degree. So which means this angle space here is 53 degree. Okay, that's the angle space from there. Okay. So now we are asked to calculate angle AOC, in quadrilateral AOCB. Now let's get it. I have AOCB. I'm looking for angle AOC. So where's AOC? AOC. So I'm looking for this whole angle here. Okay. Now how do I do this? Now I can lift out this triangle, lift it out, this triangle. So I'm lifting out triangle what? Triangle AOB. Okay, triangle AOB. So the angle here is 90. Don't forget, the angle here is 16, right? So now let's get this angle here. Okay, so now how do I get this angle? Don't forget, sum of angles in a triangle is 180. So now for us to get this angle here, that's called angle AOB, right? So angle AOB is going to be equal to 180 minus 90 minus 16, right? So which gives us like you saw 74. So 74 degree is the value here. Okay, so this angle from here to here is just 74 degree. Okay, like that. Then don't forget from theorem 3 we know that this angle, as in the angle here and here, are equal. Okay, so which means the angle from here now to here is 74 also. Yes, so which means now angle AOC is going to be 2 times 74, right? Yes, because AOC is the whole angle here. Okay, so it's like 74 times 2. Now this gives us 148 degree, right? That's the answer. Okay, now I calculate angle ADC. Okay, angle ADC. Now how do I get angle ADC? So where is it? ADC. So the angle over here. Now I can use the idea that angle at the center, okay, is twice the angle at circumference. Okay, now the angle at center here is 148. See, so this angle at center is twice this angle here. Okay, so which means the angle at circumference is half of the angle at center basically. So which means angle ADC, okay, is like half of angle half of angle AOC. So half of AOC. Okay, so now this gives us half of AOC was 148, so half of 148, so which means I have 74 degree. So 74 degree is the answer, okay, for that. So this was 148 degree. So now I says calculate angle OCD. OCD. So now for OCD. Oh, that means this angle space over here. That angle space. So now I can use quadrilateral AOCD. So let's use quad AOCD. Okay. Now in quadrilateral AOCD, okay, if I add the angles all together, this angle here was 74, don't forget. Now let's get this angle space here. Yeah, so how do I get that angle space here? I can do 360, you know, minus, now the angle space this side was 148, so 360 minus 148, so this gives us, this is 2, this is 5, this is 1, this is 2. So I have 212 here, right? 212. So which means now I can use those to get the value of that angle. So let's add. So I'm doing 212 plus 53 plus 74, right? Now if I add all those, I'm going to get what? So 212 plus 53 plus 74. Okay, so I have 339, so 339. Now the value of angle OCD is now equal to 360, okay, minus 339. Okay, now this gives us what? Minus 360. Okay, 21. So the value of OCD is 21 degree. So I have 21 degree. Okay, that's the answer. Then now let's get the last one, IV. Now we are given that the length of OA is 6. Length of OA is 6. Okay, let's make this neat. Make it neat. All right. Now the length of OA is 6. So what does that mean? Which means OA is 6 cm. Now don't forget, what I got here was 74, right? This was 16. This is 16, of course. Now we are looking for the length of AB. So I can use Sukatua, okay? So in triangle AOB, I'm looking for the length of AB. Okay, don't forget this is my right angle here. Right angle is right here. So this is my hypotenuse. So I'm looking for, so this is my opposite, of course. This is my opposite. Angle 90. This is my opposite. So I can use tangent. So I have tan 74 degree is equal to opposite. Opposite is your AB. You have your AB over, what's my adjacent, which is 6 cm. So which means my AB is going to be equal to 6 times tan what? 74, right? So the value of AB is going to give us 6 times tan 74. So I have 20.9. That's fine. So 20.9 centimeter. So this is the final answer. Okay. So now, wow. So we are done with theorem 3. Now on to theorem 4. Now theorem 4 is saying that the angle in a semicircle, okay, is a right angle, which is 90 degree. Now, what is the meaning of a semicircle? A semicircle is actually half of a circle, okay? Now, for us to get a semicircle, you must look out for the center. Center is always O, okay? Now, always look out for the diameter. So this line AB, okay, now because line AB passes through the center O, okay, that's why line AB is a diameter, okay. Now for that reason, I have two semicircles, right? One up and one down, right? So now this angle here, so if I connect point A to this point here and connect point B like that, so the angle formed here, okay, is 90 degree. That's what the law is saying. So I can also connect point A upward, join this to point B like this, okay. So if I call this point D, for example, now this theorems also apply again. So the angle formed here is also right angle 90 as well, okay, like that. Okay, now let's apply that theorem to this question. I have A, B, C, and D are points on the circumference of the circle. AC is a diameter, so I have AC. Where is AC? AC is a diameter, okay, because it's passing through the center, as you can see, right? Very good. Now BD and BC are equal, so this line BC is equal to line BD, okay. So now that means that triangle BCD, okay, is isosceles triangle, okay, since it has two equal sides, okay, which are BD and BC, okay. Now don't forget, for isosceles triangle the angles at the base are equal, right? Yes, so obviously this angle here, okay, is equal to the angle here, like that, because those are the base angles. So those angles are the same, so which means the value here is also W, all right, like that. Now I'm giving the value of angle DBC. Where is DBC? DBC, okay, as what? 62 degree. All right, now we are told to work out the values of W, X, Y, and Z, and we have to give a reason for each of our answer. Now the value of W, okay, now how do I start this question? Now what you do is that you have to look at it critically. Now angles in the same segment, okay, are equal, so which means now the value of y is 62 degree, okay, because y is in the same segment as this angle here, okay. So this one, they are in the same segment, so that's the reason there. Now the value of y is 62 degree, okay. Now the reason you write is you write same segment. Now this is actually another theorem that we'll look at, okay, much later, okay. But for now, just know that angles in the same segment are equal, all right. Then now the whole angle here is 90. How do I know that? Because this is a semicircle, so that means W plus X will give us 90 degree, okay. And the reason is what? Angle in a semicircle, okay. That's from theorem 4, all right. Okay, and again, don't forget, I just got the value of the value of W of Y. So this is 62 degree, all right. Then now what we can do is that now, because W is here, okay, W now in triangle, now put your eyes in triangle BCD, okay. Now in triangle BCD, don't forget, triangle BCD is isosceles triangle, so which means the base angles are equal. So if here is W, okay, this angle here is also what? W as well. So I have 2W then plus 62 degree is equal to 180 degree. Okay, so which means that I'm gonna get 2W is equal to 180 minus 62 degree will give us what? So 180 minus 62 degree will give us 118. So I have 118 here. 118. Now divide both side by 2. Divide both side by 2. So my W is equal to what? This should be 59. So I have 59 degree for W. Okay. And now the reason for that is base angles. Yes, you can call it base angles of isosceles, okay, triangle. Now for us to get the value of x, don't forget we just said W plus x is 90 degree, and the reason for that is angle in a semicircle, right? So which means the value of x will be equal to 90 minus W, right? So I have 90 minus 59. Okay, so my x is equal to 31 degree. 31 degree. So now the reason for that is semicircle. Okay, angle in a semicircle being 90 degree. Now finally for z, how do I get z? Yeah, so z is this angle space right here. So now don't forget, this is 90 degree. This is 90 degree. Now in triangle ADC, okay, I can get z from there. So when I add 90 plus 62, this gives me 152, right? Now the value of z is going to be 180 minus 152, right? The value of z is going to be 28 degree. So z is 28 degree, and the reason for that is just angles in a what? Triangle. Okay, angles in a triangle. So this is the reason behind z. Right? Now pause the video and solve this task using the theorems we have learned so far. So please pause the video, attempt the task, okay, using the theorems you have learned so far. Okay, so you can you can leave your comment or answers, okay, in the comment section. I will duly respond to all the comments or questions you have. Okay, now theorem 5 is saying that the angle between the tangent and radius is 90 degree, which is a right angle. Now don't forget, I have my tangent line, which is line ABC. Okay, so now my radius here is actually line OB, right? Line OB. Now my tangent line is line ABC. Okay, now the angle between them, this angle here, this is 90 degree. So the angle between a radius and a tangent is always 90 degree. Okay, that's what theorem 5 is trying to say. Okay, now let's solve this question using that theorem. In the diagram, I have BCF. Where is BCF? BCF, okay? BAE are tangent to the circle at point C and A respectively, okay? Now AD is a diameter. AD diameter, so which means this should be the center of the circle. O. That means O should be there. Okay. Then an angle ABC is 40 degrees, which is here. Now A says explain why triangle ABC is isosceles triangle. Okay. So triangle ABC, let's say triangle ABC. Now I say explain why it is isosceles triangle. Now don't forget, recall if you recall the law, theorem 3 we did. We say two tangents drawn to a circle from the same point outside the circle are equal in length, right? So if you apply that theorem here, now you will see that it's true. So AB is equal in length to BC, okay, because they are basically two tangents drawn from point B. So now because line AB is equal to line what? Line BC, okay? So that concludes that triangle ABC is an isosceles triangle, okay? Now for B, it says calculate the size of angle CAB. CAB. So this angle here. So now, how do I get the value of CAB? So which means let CAB be Y. Okay. Now, don't forget this CAB is the base angle of triangle ABC, and don't forget for isosceles triangle, the base angles are equal. So this angle here is also a base angle. So this angle should also be equal to Y as well, right? So I have 2Y, plus 40 is equal to 180, right? Now the reason must always be in a bracket, okay? The reason for this is what? The reason is sum of angles in a what? Triangle, okay? So now for your exam, always write your reason in a bracket, okay? It's very important. So I have 2Y is equal to what? 140. So the value of Y is actually what? 70 degree. So which means the value of CAB is 70 degree, okay? So CAB 70 degree. Okay. Now let's get the value of DAC. DAC. This angle space over here. Yeah, that angle space over there. DAC. Now don't forget the theorem 5 just said that the angle between tangent and radius is what? 90 degree. So now which means this line OA, okay, OA is a radius. So the angle between that line and this tangent is 90 degree, of course. Now if the value of Y here is 70 degree, okay, then this angle space here is going to be 20 degree. So that solved this question. So the value of DAC is 20 degree, okay? Now let's get the value of ADC. ADC. So this angle space over here, like that. Okay, now I know the value of okay, so this angle space over here is this is 70 degree, which is Y. Now don't forget the angle in a semicircle. Wow. So now because this is a diameter, so this is a semicircle. So the angle over here is 90 degree. 90 degree over here, okay? So with that I can get the value of ADC. Now in triangle ACD, okay, now the value of ADC is going to be 180 minus 90 minus 20, right? So this gives us 70 degrees. So 70 is the answer for ADC. So here's the math scheme, the answer for it. Okay. Now We are done with Theorem 5. Now on to Theorem 6. Now Theorem 6 is saying that the angle at the center of a circle is twice. It is twice, or you can say it is double, the angle at the circumference. Now this theorem is very, very important. Now what he's saying is that I have an arc. So this is my arc here. So now this is my minor arc. Okay, this is my minor arc. Okay, so and this is the major arc here. This is the major arc. So now this minor arc AB subtends angle 2x. As you can see, 2x at the center, right? And now this same minor arc AB subtend angle x at point P, right? Circumference. Wow. Now what this theorem is saying is that the angle that this arc makes at the center, which is 2x, so is twice the angle that the same arc makes at the circumference. Okay, so if the value here is x, the value here is going to be what? 2x. That's it. Now same thing happens here. So this my arc AB, you can say it makes an angle at the center, right? And the same arc also make an angle at the circumference at point P. So now the angle made at the center is twice the angle made at the circumference at point P. So if the value of the angle at point P is x, the value at point O has to be 2x. Okay, now this is case 3. Now case 3 is a very special case, very special. Why? Because now in this case my the angle made at the center is actually the reflex. So we are going to be using the reflex angle made here. Okay, take note of that, not the obtuse angle made. You must use the reflex angle made. Okay, so this reflex angle made here, okay, is twice this angle made at point P. Okay, that's what we have there. Now let's apply that theorem in a question. The diagram shows a circle, center O. All right, find the value of z. So that if I call this if I call this arc PQ, now this arc makes an angle, this angle, okay, at the center. Now this angle made here, okay, according to Theorem 6 we just saw now this angle made here, okay, is twice this angle made here, right? Exactly. So which means the angle made here will be 2 times 58. Okay, so this gives us this 116 degree. Now for us to get the value of z, okay, I have to use the I have to do 360 degree minus 116, right? And the reason is just sum of angles at a point. Sum of angles at a point is equal to 360 degree. Okay, now for us to get the value of z, subtract 116 from 360. Okay, so I have 360 minus 116, so I have 244. So the value of z is 244 degree. That's the answer. Okay, now for this, in the diagram, A, B, and C lie on the circumference of the circle. Okay, so A, B, C, like that. It says work out the size of the angle ACB. Angle ACB. So angle ACB is the angle space over here. Okay, that's the angle I'm trying to get. Okay, now don't forget triangle AOB. Triangle AOB is isosceles triangle. Why? Because side OA is a radius, okay, radius, and is equal to side OB, okay. So those are radii, they are equal. So that's why triangle AOB is isosceles triangle, okay, like that. So which means, now don't forget, the base angles have to be the same. So if this is 28, this is also what? 28, right? So if I do 28 times 2, that is 56 degree. Now the value of the angle over here, now the value of angle AOB I have to subtract 56 from 180, right? So which means I'm going to get so I have 180 minus 56, right? So I have 124. So I have 124, okay, degree. So now, so which means the angle on here is 124 degree. Okay. Now, but don't forget, it says give a reason for each step of your working. So when solving, you must give reason. So the reason here is sum of angles in a triangle, right? Okay, that's the reason here. So we must give reason for each step. Now, applying this theorem 6, okay, now we have that this angle made at the center is twice this angle made here, okay. So which means obviously this angle here now is going to be, so angle ACB is going to be half of what? 124, okay. That gives us 62 degree. So the angle here is now 62 degree, okay, and that's the answer. So pause the video and attempt these tasks, okay, based on the theorems you just learned, okay. Okay, so let's solve this together. Find the value of x. Now, of course, you can see that the value of x is the angle at the center. So x is twice 56, right? So I have 112. That's the value of x. Now for the value of y, is going to be equal to the value of this angle here, okay? The value of y is 56 degree because they are angles in the same segment, okay? So pause the video, attempt this and this. And this as well. Attempt this. Okay, now let's tackle this. I have A, B, and C lie on a circle center O, alright? So I'm giving all this information. So find the value of y. Now this question is this special case. That's called case 3. Case 3. Now this case 3, don't forget, you have to use the reflex angle at the center. Okay. So that means that I'm going to use now the reflex angle. My arc is arc AC, of course. Now the reflex angle over here, okay, is what we are going to use, okay. So that reflex angle there is actually 360 minus 3y, right? So that is the value of the reflex angle over there. Now that reflex angle over there is twice this angle here, okay? 4y plus 4, like that. So this gives us a simple equation which we now solve. Okay, so I have 8y then plus what? 8. So I have 360 minus 8 is equal to what? 8y plus 3y, right? So this is 352 is equal to what? 11y. So the value of y is going to be 352 over 11, and this should give us, so we have to find the value of y actually. So I have 352 divided by what? 11. So this gives us 32. So the value of y is 32 actually, and that's the answer, 32 degree. Okay, so now we are on now to theorem 7. Now theorem 7 is saying that the angles in the same segment are equal. Angles in the same segment are equal. Now what does that mean? Now this means that now you can see that this is my arc, okay, arc AB. Now this arc makes angle P, right? Angle P at this point P, right? And now this same arc, so make sure that you are tracing the same arc, okay? This same arc AB makes angle Q, okay, at point Q, right? So now, because this same arc AB makes angle P and angle Q in the same segment, so that means angle P is equal to angle Q, okay? So they are in the same segment. So the reason is because they are coming from the same arc, you get, AB, and of course they are in the same segment, so they are equal, right? Now the same law applies here. So this is the major arc, okay? Now this major arc makes angle P at point P, right? This same major arc makes angle Q at point Q, right? So angle P and Q are equal. They are also in the same segment, so they are equal, okay? Now I have a question here. Let's apply that law. The chord PRO, I have a chord. My chord is PRO, PR and SQ, okay? SQ. So I have two chords there. Now those chords, they intersect at point T, of course. So which means this angle over here is 117 degree. Okay, this angle is vertically opposite to this, okay? So they are equal. Now we are given, so we have to find the value of x and y. So what you do is that if you look at this arc RQ, okay? Now at RQ makes, if I trace on RQ like this, so RQ makes angle of x, right, at point P. Then the same RQ also makes, you say the same RQ also makes angle of 21 at point X. So now this means that because this arc RQ, okay, makes angle X at circumference, and the same RQ also make 21 at circumference, and these two angles are in the same segment, so which means X is equal to 21. Okay, that's the reason. Now the reason here is going to be, what? Same segment. So S is in the same segment as 21 degree, okay? Just like so. Now I have, so the value of S is 21 degree. Now with that, this angle is 117, okay? Now with that, I can get the value of y. So I can do 117 plus 21. Okay, this is 138. Then the value of y is going to be 180 degree minus 138, right? This is because of the sum of angles in triangle PTQ. Okay, this is 2, this is 17, this is 42. The value of y is going to be 42 degrees. Okay, so here's the mass scheme: x 21, y 42. Okay, now theorem 8, it says that the opposite angles of a cyclic quadrilateral, okay, add up to 180. Okay, or we can say that opposite angles of a cyclic quadrilateral, you can say they are supplementary. So supplementary means that they add up to 180 degree. Okay, the same thing. Now, first of all, we have to know what exactly is a cyclic quadrilateral. Now, a cyclic quadrilateral is actually a four-sided plane shape. Okay, now it has all its four vertices touching the circumference of a circle. Okay, so now you must make sure that the four vertices, now you can see, now I have quadrilateral A, B, C, D in this case. Now my vertices here are A, B, C, and D. This should be here. Sorry, this should be here. Okay. Now you can see that those vertices are all touching, okay, the circumference of the circle. So you must make sure that they must all touch the circumference. Very important. Okay. So now that's what makes it a cyclic quadrilateral. Okay. Now, what that theorem is saying is that the opposite angles add up to 180. So, which means this angle over here, angle A, is opposite, is facing which angle? Is facing angle C, right? So, which means when I add angle A and C, I will get 180 degree. Okay, that's what the theorem is trying to say. Then angle B is opposite, is facing which one? Is facing D. So when I add B plus D, I will get 180. Okay, that's just what they are trying to say there. Okay, now, but very important, you must make sure that all the four vertices, okay, of your quadrilaterals are all touching the circumference of the circle. Okay, very important. Now, theorem 9. Now, it says that each exterior angle of a cyclic quadrilateral, okay, is equal to the interior angle opposite to it. Yes. Now, what is it saying? That if I have a cyclic, now this is a cyclic quadrilateral, right? Now, because all the four vertices are all touching the circumference, right? 1, 2, 3, 4. Now it's saying that if I have an exterior angle, so which means if I extend this line, this side DC, okay, extend it out. Now this angle that's outside, okay, is theta. Now this angle outside is called the exterior, okay, exterior angle outside the cyclic quadrilateral. Now this theorem is saying that this exterior angle outside is equal to the interior angle opposite to it. So which means now the interior angle opposite to this theta is this one here, of course, this one here. That's why this angle is also equal to theta, okay, like that. So now if I should extend this line like this, so I will get this, okay. So this is now my exterior angle, right? Now if this angle is x degree, so now the interior opposite angle is going to be what? This one, right? Is this. So this also x degree, like that. That's what Theorem 9 is trying to say. Now with that, let's now solve these questions. Of course, so these are all cyclic quadrilaterals. So from the theorem we just learned, so if I add p to 95, okay, I'm going to get 180. Why? Because p is opposite to 95, okay? Don't forget, opposite angles are what? Supplementary, right? In a cyclic quadrilateral. So the value of p will now give us 180 minus 95. So the value of p is going to be what? It's going to be 85, right? Yes, 85 degree. Okay, now the value of q, this q is opposite 75, so which means the value of q is going to be 180 minus what? 75 degree, right? So my q is equal to my q is equal to 105, okay, degree. That's it. Now for this question, we are looking for the value of b, okay? Now we are going to apply this Theorem 9 we just learned. Now this angle b over here, okay, is the exterior angle, right? Now that exterior angle is equal to the opposite interior angle, don't forget. So which means that b is equal to this 60 degree, this one here, okay? Because this is the interior opposite angle, so b is 60. Now let's solve this one. So the value of, okay, this is easy. So now this is your task, so you should solve g, okay? So now find the value of p, find the value of q, okay? Now let's solve f. X is opposite to 86, so the value of s is just 180 minus 86, because that's a cyclic quadrilateral. So the value of s is going to be what? 94 degree, okay? Now the value of y is going to be 62 degree, 62 degree, because this y is the exterior, right? Exterior angle. So don't forget, we said the exterior angle is equal to the opposite interior angle, right? So my y is 62, okay, degree. Now how do I get the value of z? Okay, so which means I know this angle here. Now this angle here is also exterior. Now this angle here is also x, yeah, because this is like exterior angle. This is x, yes. So basically s plus y plus z is equal to 180 in this small triangle I have here, okay? I got s as 94, I got y as what? 62, then plus z is equal to what? 180. Now the value of z is going to be what? 180 minus 94 minus what? 62, right? So you can finish that and get the value of z, okay? Just like so. Now let us tackle this question. Now I have A, B, C, D, E is a pentagon. A, B, C, D is a pentagon, okay? A circle center O, all right, passes through the point A, B, C, D, and E, okay? So I have all this information. Now AB is parallel to DC, okay? So that means side AB, okay, side AB and side DC are parallel, okay? Now if they are parallel, so which means I already have what we call alternate angles already, okay? So which means this angle x is equal to this, so this is 78, of course, degree. Now I say find the value of x, y, and z, given the reason for your answer. Now the value of s is 78. Okay. Now the reason is alternate angles. Okay. Alternate angles. Don't forget, you must give your reason in brackets. Okay. So I have s already. Then how do I get the value of the other letters? Now if you look carefully at this shape A E D C, A E D C, now that is a cyclic quadrilateral. Why? Because all the vertices A, E, D, and C are all touching the circumference of the circle, right? So that makes it a cyclic quadrilateral. Okay. Now angle Z is opposite towards to X, so which means they are supplementary. So now for us to get Z, I'll just do 180 minus 78, right? So the value of Z. So now the reason, say give a reason for each step. Now the reason here, you can write cyclic chord. That's fine. The value of Z here is going to be 180 minus 78. I have 102. So the value of Z is 102. Okay, degrees. Now the value of Y is going to be, now Y is opposite 36. So which means Y is 180 minus 36, right? So this is 144. And the reason is also opposite angles, of a cyclic, quadrilateral. Okay. So I have my X, Y, and Z already. Now B says explain why ED is not parallel to AC. Okay, so line ED, where's line ED? ED. So we are trying to explain why it's not parallel to AC. Okay. Now the reason why they are not parallel is because now if you know, if you look at two parallel lines, now for example, now if they are parallel, for example, so if they were parallel, this is ED, this is AC. Now if they were parallel, okay, now this is a transversal line, for example. Now this angle and this angle will be co-interior. So that means if they were parallel, okay, so when I add Z to this, to 36, I should get 180. Now but let's check. Now if I add Z to 36, am I going to get 180? The value of Z was 102, then plus 36. So this is not 180 degree. So now because when I add this this angle, okay, this Z, okay, and 36, so I'm not getting 180. That shows that those lines are not parallel, okay, because they do not give me a co-interior angle there. Yeah, so this is a mass scheme. So because Z plus 36 is not giving me 180, okay, that's why they are not parallel. Okay. Now because if I had gotten 180, so that shows that they are parallel. Okay. All right. Find the value of EOC. Value of EOC. So I have EO. So I have to join. So let's join E to O and to C. I'll get this shape. So EOC, this angle over here. So how do I get that angle? EOC. EOC. All right. Now, for us to get that angle EOC, what we can do, okay, what we can do is very easy. Now we have to look at arc. Look at arc EC. Okay. Now arc EC subtend and this angle EOC at the center, right? Now don't forget, from that theorem we learned before, the angle made at the center is twice the angle made at where? Circumference, right? So which means this angle made here is 2 times 36, because arc, if you trace arc CE to the circumference, it makes 36 degree, right? So which means the angle made here is double of 36. So the angle here made here is 2 times 36, okay? And the answer is 72 degree, okay? And the reason I'll give here is that angle at center is equal to what? Is 2 times angle at where? At where? Circumference, okay? Now lastly, we have that AB is equal to AC. Find the value of angle ABC. So if AB is equal to AC, where's AB? If AB, okay, is equal to AC, where's AC? AC, okay. Now if that is true, so which means triangle ABC is now an isosceles triangle, right? Isosceles triangle. So the base angle, so which means the angle over here and the angle here are base angles, so they have to be the same. So if I call this T, I call this T. Now let's solve for T. So I have T plus T, plus 78, okay, is equal to 180. And the reason for this is sum of angles in a triangle, right? So I have 2t is equal to, now 180 minus 78 will give us what? So I have 180 minus 78. That gives us 102. So 102 will be here. So the value of t is going to be 51 degree. Okay, so here's the math scheme for that question. Okay, so you can pause the video and apply what you just learned now, okay, to solve this question. All right. This as well. This as well. Okay, now so this is the last theorem that we'll be considering. Now it's called the alternate segment theorem. Now it says that the angle that lies between a tangent and a chord, okay, take note, a tangent and a chord. So the angle between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. Now what that theorem is trying to say is that if I have a tangent, now this is my tangent line, right? Now this P is the point of contact. That P is the point of what? Point of contact, right? So my chord, so that let's label it. So let's call this point A, this point B, let's call it point C and point D. So my tangent is CD, right? Then my chord is BP, right? Now this theorem is saying that the angle between this chord BP and the tangent, which is this angle over here, right? This angle here. Now that angle is equal to the angle in the alternate segment. Now the angle in the alternate segment is actually this angle here, this one here. Now but you must make sure that the angle must be formed by this same chord. So which means you have to like connect point B like this and connect point P like this. Okay, so this angle in this alternate segment must be formed by this same chord. Very important. Okay, so now the angle, if here is like x degree, this also x degree, they are equal. Okay, that's what the law is trying to say. Okay, so this is the angle between the chord and the tangent, this one here, and this is the angle formed in the alternate segment. Okay, so they are of course they are equal. Now I have A, B, C, D is a cyclic quadrilateral. All right, tangent at C and D meet at point E. All right, so my tangents are actually ED and what, and EC, right? Now they meet at point E, of course, point E outside the circle. Now from the theorem, from the previous theorem that we've learned before, you see that tangent ED is equal to tangent EC. Of course, they are equal in length. So which means that triangle CDE is definitely an isosceles triangle. Okay, so which means if here is Q, so this angle is definitely what, also Q, of course. That's a fact. Now we are to calculate the value of P, Q, and R. Now if I apply this last theorem I just learned, alternate segment theorem, now you see that my chord, now look at chord AD. Look at chord AD, right? Now this chord AD, the angle between chord AD and that tangent, this tangent DE, is 75 degree, right? Now this 75 degree is equal to this angle in this alternate segment here. So this is 75 degree. So this is exactly how to apply the last theorem. Okay, so I have 75 degree over here. Okay, then now I can come again. Now you can see that I can do 75 plus P plus Q is equal to 180. Now the reason for this is sum of angles on a straight line. You know, this straight line here, sum of angles on a straight line, right? Good. So which means P plus Q is equal to 180 minus 75, right? So which means P plus Q, of course, is equal to, so 180 minus 75 is equal to what? Is equal to 105. So I have 105 here. 105. So you can call that equation 1. Okay, then now you see that okay, if you look at this now I have A, B, C. This is cyclic quadrilateral. A, B, C, D. Now which means this angle 126 degree and P, they are opposite, so of course they will add up to give me 180. So which means I have 126 plus P will give us 180. Why? Because they are opposite angles in a cyclic quadrilateral, right? So now the value of P already is 180 minus 126. So the value of P is definitely going to be 54. So my P is 54, okay, degree. Now I have the value of P. I can use P to get Q. So now Q is equal to 105 minus what? 54, right? So the value of Q is going to be this is 51. So my Q is 51 degree. Okay, now I can use, okay, very good, I can use this property here. Don't forget this is on Q. Okay, this is base base angle of that isosceles triangle. So let's add up. So I have 2q, plus r is equal to what? 180, right? So I know q before. Q was 51. 2 times 51 plus r is equal to what? 180, right? This is 102 plus r is equal to what? 180. So my r will give us 180 minus what? 102. So the value of r is going to be what? 78 degree. So I have 78 degree. Okay. So now you can pause the video and attempt this task. Okay. All right. So lastly, before we end the class, let us quickly take the last task, which is this very task, this one. Now I have point A, B, and C lie on a circle center O, okay, with diameter AB. So the diameter is AB, okay. So we are told that BD, OCE, BD, OCE, and AF, they are all parallel lines, okay, parallel lines. So angle CBD is 68 degree, okay. Now we have to find the value of angle BOC. BOC, where is BOC? BOC. This angle space over here, okay, just like that. So now for us to get the value of BOC, okay, what should I do? I can get the value of BOC by making use of the fact that now since these lines are parallel, I mean line BD and line CE, since they are parallel, so which means this angle over here, okay, is going to be, don't forget, the angle BCE, okay, is co-interior to 68. So angle BCE is going to be 180 minus 68, right? Because they are co-interior angles. So what I'm going to get there is 180 minus 68. So that gives me 112. 112. So the angle here is 112. 112 degree, right? Then now, having known that, then now pay attention. Distance from O to B is a radius, is equal to OC. So which means triangle OBC. Triangle OBC is isosceles triangle. Yes, and the base angles are actually here. This and this. So if I call this Y, call this Y. So with that, I can get what I want, okay? So now the value of Y, actually, now if you look at this straight line at OCE, the value of Y is going to be 180 degree minus 112, okay? That gives us 68 degree. So that is the value of Y. Then using that, I can do 68 degree times 2, double it. This gives us 136 degree. Now the value of angle BOC, okay? So I'm using triangle OBC now, okay? Because I just got the value of Y, right? Which is 68. So this is Y, another Y. So double it, 136. Now I want to get the value of this angle here, this one. So I have 180 minus 136, right? Now this gives us 44 degrees. So the value of BOC is 44 degree. So this is the mass scheme, 44 degree, okay? Now the value of ACE, let's get ACE. ACE. So I want the angle space over here. The angle space over there. So now you can see that obviously this side are also equal. They are the same. So now if the angle over here is 44, Okay, so if here is 44, so now how do I get this angle space here? So you can use straight line. So this is like saying 180 minus 44, right? So 180 minus 40, that's 140 minus 4. This is 136, right? So this angle here is 136 degree. 136 degree over there. Okay. Now let's call this angle. Call it A. So this is A, and this is also A because they are base angles. Okay. So I can have 2A, 2A, then plus 136 is equal to what? 180, right? So 2A is equal to 180 minus 136 give us 44. Now the value of A is 22. So that means that the angle over here, okay, is the angle here is 22 degree. 22 degree, okay. Now if that's true, wow. So I can get it. I can get what I want basically. So which means the angle I'm looking for now is actually angle ACE. So angle ACE is not going to be 180 degree minus 22 degree. So this should give us 158. Wow, and it's correct. So that's what you have here in the math scheme. Okay. So wow, finally we have come to the end of circle theorems for IGCSE, for WAEC, and for JAM, and for Edexcel, and for AQA exams. So no matter the exam you are preparing for, this is a very perfect and wonderful tutorial for you. So we have touched the whole of circle theorems. Okay, so please pause the video and attempt the task so I can have a complete mastery of the concept. Okay, so don't forget to subscribe to the channel. So if this video really helped you, please subscribe to the channel and like the video, comment on it, share the video to your friends, to students that really needs the video. Hit the like button, turn on the notification button. Alright, so it's a wrap up. See you in the next video. Remember, it's Number Ninja.